Hello guys, now let's see the main working principle of the STP. First, the protocol is based on the shortest path algorithm, and which can go through 4 steps in building a loop-free tree structure through the algorithm. Our main function of STP is used to avoid the loop, right? And we have to select which interface should be blocked and which interface can continue to help us to follow the message. And how to select? There are 4 steps. The first one, we have to select one root bridge. And pay attention, before we use a switch in our network, we create the device we call it bridge. So in this course, if we see some bridge, that means we see the switch. And on the same layer 2 network, we have to select one switch to become root bridge, and this one we call it root. And the rest of switch we call it non-root bridge. And on all non-root bridge, we have to select one root port, one non-root bridge, only one RP. And the second one, we have to select the designated port, we call it DP. If all the interface not become RP, not become DP, we have to block the interface, and this one we call it alternate port, we call it AP. So there are main 4 steps. And then let's see how to select who is root bridge, how to select what's the interface rule to become RP, DP, or maybe blocking interface. We have to compare some parameter. For example, something like the priority of the switch, the priority of the interface, something like this. And all of the message will be added into the BPDU. We call it Bridge Protocol Data Unit. All the switch will communicate and exchange the BPDU message, and then in the BPDU, we will see lots of parameters of the other switch. Then we can communicate with each other, we can compare and select the final rule of the switch and the interface. Like the topology of switch 1, 2, and 3, if we add the configuration of the STP, then the switch will select all the priority message or all the parameters of the priority of switch of interface, add into the BPDU and encapsulate to become the BPDU message, and then we will send out. When the switch receives it, we will compare the message, the parameters from the other switch and with my side. And finally, to agree, you will become the root bridge, or maybe I should be the root bridge, something like this. So the BPDU is very important. Of course, you don't have to do the encapsulation of the BPDU. You only have to add the configuration of STP. Then the switch will send out the BPDU automatically based on some principle. So this is a BPDU. And about the BPDU, this one is very important, right? And we will add lots of parameters, and finally to design the rule of the STP. We will find some key points like the protocol identifier, the protocol version, because we have 3 types of version, right? STP, ISTP, and MSTP. Different type version STP, we will carry different parameters. And what's the BPDU type, flag, something like this. And later I will explain one by one for you what's the detailed parameters and what's the function. And about the right one is the typical, we can use some tool like the Wireshark to get the message, and we can see some detailed value like the bridge priority to become 3276A, and what's the system, the bridge system ID, right? And usually the system ID should be the MAC address of the switch. So something like this. And we will have some time message like the max age, the hello time, like the forward delay. And later, let's say the detail, what's the function of the STP. And the total length of each field, we have 1, 2, 3, 4, 5, 6. Totally should be 12 segments and 12 parameters of the STP. The first one for the protocol identifier. This is 2 bytes long and always be 0. And this will show you this belongs to the BPDU message. And this one you can skip it because the value is fixed to become 0. And the second one about the version, we have 1 byte long. And 0 means STP, 2 means ISTP, and 3 means MSTP. So if we have different value of the version here, the rest of message we will take the special protocol and use a principle. For example, if the value becomes 0, that means the rest of message we will calculate according to the STP principle. And the message type, we have 1 byte long. In 00 means this is the C BPDU. C means configuration. We have 2 types of BPDU on STP. The first one is now we have to connect with each other of the switch, and we have to calculate which interface should become DP, which should become RP, which interface should be blocking. And this process we call is the STP calculation. And we will communicate with each other by the C BPDU and later decide the rule of the interface. So this BPDU is responsible for establishing and maintaining STP topology in order to avoid the loop. And the second type of the BPDU we call is TCN BPDU, because the second function of the STP is if one link is broken, we still have to get the backup link to help us to force the message out, right? And maybe we have lots of blocking interface, which interface should be continue work. And the key point is we also have to let all the switches to delete the wrong MAC address because now the topology is changed. So who will help us to do the work? We will use the TCN BPDU, topology change network BPDU. And later we also will have one part to introduce the TCN BPDU. And this one will be used on the network topology changes. So this is a message type. And the second one is flag. Flag is 1 byte. The lowest bit is TC flag, the topology change. The most signal bit is TCA topology changes acknowledgement flag. And 1 byte means we have 8 bits, right? But on the STP, we only use the lowest bit and the highest bit of TC and TCA. Once the network topology is changed, we will use these two. And the second one is the root ID. We have 8 bytes long and indicates the RID of current root bridge, like the root ID, because we have to select one switch to become the root bridge. And we will compare something like the priority and the MAC address. And 8 bytes means 2 bytes will become the bridge priority and the 6 byte of the MAC address. We will compare these 2 parameters and finally to select one switch to become the root bridge. Okay, so this is the root ID. And finally, who will become the root bridge? And this switch priority and MAC address information will be added into the root ID. If we do the convergence successfully, finally all the BPDU, the root ID should be same because we only have one root ID. The next part is the root path cost. We have 4 bytes long. And this one will indicate the cost of the link, because we also have to select which interface should be RP, which interface should be DP, right? And one parameter we have to compare is the cost value of each link. And this cost value will be calculated based on the bandwidth of the interface. Higher bandwidth, we will get smaller cost value. Okay, and by default, 1 gigabit interface, the cost value is 4. 10 gigabit interface, the cost value is 2. So this is the cost value. And the rest of the message, the bridge ID, also have 8 bytes long, and the format is same with the router ID, but the different function. Who send out the BPDU message, and the bridge ID is the information of this switch. So the meaning is different with the router ID. When the network topology is convergence, all the BPDU on the link, the router ID is same because we only have one root bridge, right? But the bridge ID will be different. Different switch send out the BPDU, the bridge ID will be different, right? And the format is same, 2 bytes of bridge priority and 6 bytes of the MAC address. And the next part is port ID. We have 2 bytes long. And the first byte is a priority of the interface. The default value is 128. And the second byte is a port number. Okay. And about this one, we also compare the priority and the port ID of the interface number, and to select who will become the DP, RP, or blocking, something like this. And the priority of 128, this one we can use a command to change. And the rest 1 byte, we have 8 bits, right? The last 4 bits of the port priority and 8 bits of the port number together to make the port ID, and which is allocated by the system and cannot be modified. So pay attention about this part. And the next part is a message age. Message age, we have 2 bytes long, and indicates the survival time of BPDU message, the maximal time of port to keep the BPDU. Later, we will see the process, how to calculate the topology, how to make to become a tree topology to avoid the loop. We will receive some BPDU from the root bridge. And we will keep the BPDU on my side, keep the highest priority, the best BPDU on my side. If one link is broken, maybe we cannot do the communication with our root bridge. So I will keep the BPDU within the message age. So this is the message age time. And the maximal age 2 bytes long, the default value is 20 seconds. This is the maximal survival time. And the maximum age is 20 seconds. That means within 20 seconds, if we receive the BPDU from some switch, I will update and take the newest message of the BPDU. Otherwise, until 20 seconds later, I will think the network is broken. We have to calculate the topology again. So this is the maximal age. And how long time to send the message out depends on the hello time. By default, with the time is 2 seconds. That means about the root bridge, every 2 seconds I will send the BPDU out to let all the switches know I still online, and you have to keep the newest message from my side every 2 seconds, right? Maybe some link is broken, maybe the root bridge is broken, I will never send out the BPDU again. And maybe 20 seconds later, the rest of switch will find that the root bridge is broken. So we have to do the calculation again. So this is the function of the time. And the next one is a forward delay. We have 2 bytes long. Indicates the duration of control listening and the learning status. Later we will talk something about the status. If one switch some interface to become RP or to become DP, finally this interface maybe still have to wait 30 seconds later, and then we can help us to forward the message. So this depends on the forward delay, and the default time is 15 seconds. So when we send out the BPDU, we will add lots of parameters on the BPDU to let all the switches know what's the parameter on our network. So this is the second part. And we see we have 4 steps of the STP, right? The first one, we have to select the root bridge. The second one to select the RP. The third one to select the DP. The last one, we have to block the rest interface. Then the first one, let's see how to select the root bridge and what's the principle. This is a principle. And we have one topology of switch 1, 2, and 3, right? And by default, they will have the bridge ID, because one switch we will have the one ID, indicates the switch. And about the bridge ID, we have 2 parts, right? The first one is a priority, the second one is a MAC address. How to select who will become the root bridge? We will compare the bridge ID. And about the bridge ID, smaller is better. And the process is first to compare the priority. Lower is better. And if the priority is same, we will compare the MAC address. Also, is smaller is better. And by default, if you don't use a command to change the priority on radius switch, the default value is 32768. So this is a default. And if you don't use the command to change the priority, that means the priority is same of all the switch. Then we will compare the MAC address. But MAC address will be unique, right? Different devices will have different MAC address. So compare the MAC address. Finally, we will select who will become the root bridge. But on this topology, directly compare the priority, we can find that the switch will become the root. Switch 2 will become the root, right? Because the priority is smallest, the value is 0. And the switch 1 and switch 3 will become non-root bridge. So this is the first step. Of course, if now we directly see the topology, it's very easy to find the switch 2 is root. But in the real network, if we have lots of switches connect with each other, and all the switch will stand out about the BPDU. At the beginning, everyone will think, I am the root. So I will directly send the BPDU out to let the other know I should be the root bridge. Also, I will receive the BPDU from the other switch, right? And receive, I will compare whose priority is better. Then I will make the MAC address and the priority on the segment of root ID to let all the devices know he should be root bridge. So in the real network, they will communicate with each other by the BPDU. And of course, in the STP, only root bridge can send out the BPDU message. The rest of non-root bridge only can be forward. But at the beginning, if the switch only start, they never receive the BPDU from the other switch, I will think I am the root bridge. So I also can send out the BPDU. But later, I only will forward. The second one, we have to select who is RP, right? Let's see the principle at first. Or the non-root bridge switch, we have to select one interface to become root port. We call it RP. And how to select RP? First, we have to compare the cost value. The smallest cost value of the interface will become RP. Of course, the cost value have to connect with the root bridge. If the cost value is same, we will compare the root bridge ID. The smallest bridge ID value will become the RP, and the process is same. Compare bridge priority at first. If priority is same, we will compare the MAC address. The smallest is better. If the bridge ID also is same, maybe you have two interfaces to connect with the same switch. That means the bridge ID also is same. Then we will compare the port ID. The smallest port ID value will become the RP, and we will compare the port priority at first. If priority is same, we will compare the port number. Smallest is better. So this is a principle how to select the RP. And in this topology, now we already know switch 2 is root bridge, right? So we have to select RP on switch 1 and switch 3. And now if I let you know the cost value of each link, about the switch 2 and switch 1, the cost value is 10, 2 and 3 the value is 30, 1 and 3 the value is 20. So how to select who will become the RP? Of the switch 1, we have two interfaces to connect with switch 2, right? One is left one and another one is the right one to connect with switch 3 and then to connect with switch 2. And about the direct connect link, the cost value is 10. But pay attention about the other interface. The cost value is 20 and 30. So the right interface, the cost value to become 50. So we select the left one to become RP. So this, pay attention please, we have to add all the link to connect with the root and select the smallest one to become RP. So switch 1, the left one will become RP. And about the switch 3, let's see the process. We also have two interfaces we can connect with all the switch and then to wait the root. One direct link, the cost value is 30. And the rest interface, the link is 10 and 2 also is 30. That means compare the cost value, we cannot select the smallest one to become RP. Then we will compare the bridge ID. What means bridge ID? About two interfaces, we will receive the BPDU from switch 2 and also will receive the BPDU from switch 1. The bridge ID of switch 2 is the bridge ID 00002. But the bridge ID from switch 1, the ID is 32768. So compare switch 2 and switch 1. The bridge ID is better from switch 2. So we will select the interface connect with switch 2 to become RP, right? So this is a step how to select the RP. Of course, in the real network, the switch communicate with change the BPDU message. We will compare these parameters at the same time. Then the next step is select of the DP. Select of DP on all link. That means one link, at least one DP, to forward the message out. Maybe the other site will become DP or maybe blocking interface, it doesn't matter. One link, at least one DP. And about how to select the DP, we also compare the cost value, compare the bridge ID, and compare the port ID. It's same. So now on the topology, we will find we have three links, right? And two interfaces already know what the rule is RP, and the rest interface we have to select who is DP. And the result is About the switch 2, because this is RP, all the interface will become DP. In some scenario, some normal scenario, all the interface of the root, the interface will become DP because the cost value is 0. All the cost value we have to compare with the root bridge. So these two interfaces will become DP. And these two link, now all the interface rule we already know, right? One DP, one RP. And we have to compare the link with switch 1 and switch 3. We have to select one interface to become DP. And compare the cost value of the result. Switch 1 interface will become DP because the cost value is 10 to the root. But the other side, the cost value is 30. So we will select the switch 1 interface to become DP. And the rest of interface, we will blocking. This is the last step. This interface will become alternate port, AP. And this interface finally cannot forward the message only in the blocking status. Until maybe some interface is broken, we will make the interface to become AP again, to become forwarding status. So these are whole step: how to select the root bridge, how to select the RP, how to select the DP, and how to blocking the interface. Then let's see the port status. If we now have 3 rules, right? RP, DP, and AP, and that not means they can directly working for customer. For example, RP and DP can forward the message for customer. No, depends on the status. And about the status, we have 4 status. 4 status: blocking, listening, and learning, and forwarding. And about the blocking status, that means we have to listening to the BPDU but not forwarding the BPDU. And we were discarding all the message from the customer. And we no need to learning MAC address. And we no need to generate the MAC address table entries of this interface. About the AP, finally we will keep the status in the blocking. Because this interface is no need to forward the message. So we don't need to learning MAC address. We don't need to add the MAC address table according to the interface. And if the interface to become DP or maybe to become RP, we will go to the next data about the listening. And about this data, what's the function we can do? And we can receive and send out the BPDU if the interface on this data. But we cannot forward the message. And what's the function of this data? We have to complete the STP convergence. We have to send out the BPDU to all the switches and let them know what's the parameters of my site. And finally, to calculate what's the state of the interface. And the default time is 15 seconds. If finally we will select this interface to become RP or to become DP, we will continue go to the next data, and the data to become learning data. And in this data, the function is we also can accept and send out the BPDU to calculate the topology, but we cannot forward the message out. Because in this data, we have to help the switch to learn more MAC address table. If in the switch your MAC address table entry is more, that means you can forward the message according to the MAC address better. You will, when you receive the unicast message, it's more possible to become a normal unicast message, not about unknown unicast message. So you can directly forward the message out. Otherwise, maybe you have to flood the unknown unicast message. and the time is 15 seconds. And later, the DP and RP will enter into the forwarding state. We can accept the BPDU, forward the BPDU, and also to forward the message. So that means if the interface finally to become RP or maybe to become DP, we have to wait 13 seconds and then to forward the message out. So this is the process of blocking, listening, learning, and forwarding. Why we have to wait 30 seconds? Because we hope there is no loop as much as possible, and we hope the MAC address empty, the entry should be more is better. But this also will become the disadvantage of STP because 30 seconds is too long for us. And this is a summary. Finally, only the blocked port will become the state of the blocking. We only can receive the BPDU to test the network topology is changed or not. And we cannot send out the BPDU. We cannot learn the MAC address table. We cannot forward the date. And about the listening and the learning, we also call this is the intermediate status. No interface will finally to become these two status. And the RP and the DP will finally in the forwarding state. We can receiving BPDU, send out BPDU, but we also can learn MAC address and forward the message out. So this is the STP principle of the state. And then I will show you the topology in the real cases. This is very complex, right? Because we will have the switch, we also maybe have the hub in the topology, and we have lots of interface. And the MAC address from switch 1 to switch 6 is 111 to 666. And about the switch 1, we change the priority to become 4096. Switch 2, the bridge priority is 1892. And the rest 4 switches will use the default priority. That means the value will become 768. This is a default priority value. And about the interface, we only change the switch 5, the port value priority to become 16. All the rest interface, we will use the default priority is 128. And the cost value also is same. Also is the default value. So if we change this topology, what's the result of the status of rule? Because maybe in your network, you have to know it about the result. If your network topology is changed, you can directly to do the troubleshooting. So based on the information, please analyze the root bridge in the topology diagram and all the root ports, the DP, and the blocking interface. We can see one by one. First, compare the priority. We can directly select the switch 1 will become the root bridge, right? Because the priority is smaller. So the rest 2, 3, 4, 5, 6 will become the non-root bridge. We have to select the IP of all the interface, of all the switch. And about the switch 2, the IP will be the interface 48 because compare the cost value, this link, the value is smallest because we will use all the value, cost value is same. Maybe you can directly to use a value to become 1 or become 10, it doesn't matter. And about the switch 3, the interface 23 will become the IP. The switch 4, the 23 will become the IP. Switch 5, the 23 will become IP because they directly connect with the switch 1. And about the switch 6, let's say, we have 2 interfaces, right? And about the left one and the right one, the cost value is same to connect with switch 1 because we have 2 links to connect with switch 1. And how to select who will become the RP? We will compare the second parameter of the root bridge. Of the bridge ID. About the switch 6, 2 interface, we will receive the BPDU, both of them, from the switch 5. So the bridge ID also is same. This is the ID of switch 5. The next one, we will compare the port ID. About port ID, the left one we will receive from the first interface of switch 5. The right one we will receive the BPDU from the second interface of switch 5. But about switch 5, we will find the second interface. We change the port priority to become 16. So the priority 16 is smaller than the default priority of first interface 128. So finally, we will select the right one to become RP, right? Because the priority value is smaller. The hub cannot run the STP, so there are no any rules of the hub devices. Then let's see the next step. We have to select the DP, right? About the rule, all the interface of the root, the interface will become DP, right? And then compare the switch 3 and switch 2. This link, we will select the switch 2 interface to become DP because switch 2, the priority is higher than switch 3. The priority value is 8192, so this will become DP. And about the switch 2, the interface 46 also will become DP. 45 also will become the DP because on this link, the bridge ID priority is better than switch 4 and switch 5. And about switch 4, the interface 0 will become DP2. This is compare on the link of interface 1 and interface 2 because the port number is smaller of the interface 1. And on the link of switch 4 and switch 5, the left one will become the DP because compare the bridge ID of switch 4 and switch 5. Switch 4 is better. The priority is same, but the MAC address of switch 4 is 444, but about the switch 5 is 555. So this one will become DP. And the switch 5 2 interface also will become DP because the cost value is smaller to switch 1. And the rest interface, we have to block it. All of them will be blocked. So this is the result of all the interface. And another question is, based on the result, please analyze what other problem exists in the network. Because now we already found all the status or all the rule of the switch and the interface, but the rest of the hub, right? The left there is a hub. There also is a loop. And the hub cannot run the STP protocol. So in this topology, the loop of the hub cannot solve. This is the rest problem still exists in our network. So how to solve this problem? We also have lots of technologies, but this is not the main principle of STP. We will skip it, okay? So we already talked something about the basic BPDU and how to use the BPDU to calculate the topology and how to select the rule of switch and the rule of interface, and finally what's the status. So this is a basic function of STP, and we have to calculate the tree topology to avoid the loop. And the second function is if one active link is broken, how to make the backup link. We also can call this as a blocking interface to become active and continue to help us forward the message as soon as possible. In this scenario, we will use a new BPDU. We call it TCN BPDU. And how to work about the TCN BPDU, we can see in the next video.